All right, folks, welcome once again. Welcome to day 7, right? So this is day 7 of our 15-day course. We are, of course, in week 2 as well. And today we will be looking at module 5, which is database services. Okay, so in the agenda that we have for this course, right, what we have done so far is EC2, right, EBS and S3 in storage, and VPCs yesterday. Okay, so we've done compute, storage, and networking, right? And of course, we've not looked at all the services under each category, but we've looked at the main ones, right? The most important service or services under these three categories, right? And today we look at four, or rather, we'll start module 5, and in this module we're going to look at 4 database services, and each is different. You know, each database service is different. They offer different kinds of value. So we need to understand all of these, and then so that you can, you know, in your design, in your architecture, you can pick and choose which ones are most suited for a particular type of problem. Okay, and in the cloud, databases are easy to set up. So now it's possible in the cloud to have applications or stacks which use multiple database technologies, right? So so that's what we're going to talk about. And overall, you know, with this module, we'll be finishing, we'll be completing the basic building blocks, right? So if you know EC2, if you know S3 and VPCs now, because you know, from a security perspective, they're better, and if you know RDS, especially in databases, right? So once you know these 3, 4, or 5 services, you are well on your way to using AWS in your projects, right? Most people use these 3, 4, or 5 services. They don't use the other services, especially when they are beginning with AWS, right? So this will be an important milestone in the course. We'll be finishing up the basic building blocks of your stack. Okay, so what we're going to do is we'll start module 5 today, and based on experience, what I've seen is we typically need more time, more than 3 hours. So we'll probably use up the entirety of tomorrow as well on database services. All right, so module 6 we will start most likely the day after tomorrow. Okay, so let's do a quick review first of module 4, right? And then we'll look at the agenda for this module. Okay, so in module 4, we were looking at networking services, and our focus was on virtual private cloud, VPC, right? And the goal here was to get you started with VPCs, help you set up your first server inside of a VPC, right? And today as well, you know, when we look at databases, we'll try and set up an RDS instance inside a VPC as well. Right, so that was the goal of the module, but we had to understand several aspects of a VPC. Different. First of all, you know, what a VPC is, what are the benefits of it, and also we had to understand the components that make up a VPC. And then we looked at those 4 scenarios as well, right? And then finally, we implemented one of these scenarios using the VPC wizard, right? So that's what we did. Now the VPC is a virtual private cloud, right? So it's a private cloud. You know, it's not a full and proper private cloud, because a private cloud is one where you have cloud-like features in a company's own infrastructure, right? So the infrastructure should be owned and operated and controlled by the company, let's say a bank, right? So that's a private cloud, but this is not like that, right? A VPC is not like that in the sense the infrastructure is owned and controlled and operated by AWS, right? However, a VPC does give AWS customers an isolated network, right? So it's possible to create a network which is not connected to the internet at all, right? Also, it has some additional security features like the ACL, the network ACL access control list that we spoke about, the additional firewall, right? So a VPC goes halfway, right? It's not a full private cloud, but functionally at least it gives you the network isolation of a private cloud, right? And also it gives you the option of having dedicated instances, right? So those two capabilities make it like a private cloud. That's why it's called a virtual private cloud. Okay, and the benefits are, of course, basically the network isolation, the additional firewall, the dedicated instances. These are the benefits, right? And a lot of the larger companies and also some of the industries which are more sensitive, financial services, banking, healthcare, right? So those kinds of companies will prefer, will obviously like the fact that there's a VPC service available, right? And also, like I mentioned to you yesterday, the VPC, it looks like AWS is making the VPC the default, or rather, it's making it mandatory, right? It's making it mandatory, and I think you'll not be able to, especially newer accounts like yours, you probably will not be able to launch instances outside of a VPC, right? It's called EC2 Classic, and it's possible that you're not able to launch instances outside of a VPC, right? So it looks like AWS is headed towards making VPCs mandatory, right? So that's why it's important to learn VPCs. Okay. Also, it's important to learn VPCs because most people are not familiar with networking aspects, right? As much as they are with, say, databases or applications, DevOps, and so on, right? So that's another reason that you have to, pay a little more attention to VPCs, right? It's something maybe unfamiliar to you. Okay, all right. Now, as far as the components are concerned, we spoke about various things like subnets. Right, there's public subnets and private subnets. Remember that each subnet has to have a route table, and the rules in those tables define how the network traffic will flow within the VPC and also between the VPC and the outside world. Right. Also, some of the other components like the internet gateway, the NAT gateway, and the VPN gateway, right? These are sort of gateway services, managed. They're managed services, fully scalable, right? And these are the components that allow for communication. Say the NAT gateway, for example, allows for outbound communication from the VPC. The internet gateway allows for bidirectional communication, right? And the VPN gateway is obviously for a VPN connection from your corporate network to the VPC, right? So these are some of the major components. Also, there's a ACL access control list or an NACL network access control list, right? So this is an additional firewall in addition to the security group that we have always used, right? So there's an additional firewall, two firewalls, two layers of security available in a VPC. Okay, all right. Now the four scenarios we discussed were, the first one was very simple, just a VPC with a public subnet. The second one had one public and one private subnet, right? And 3 and 4, scenarios 3 and 4 are very similar to 1 and 2, except that there's a VPN connection from your corporate network to the VPC, right? So if you learn 1 and 2, you're well on your way to learning 3 and 4 as well. Okay. Also, one more important point is that when you try to implement a VPC, remember there'll be a default VPC already present, right? And that default VPC has very loose security rules. Okay, so the ACL is ineffective. All the subnets are public subnets. So that VPC should be used only for learning purposes, right? When you're new to AWS, you should create your own VPCs. When you start becoming more serious with AWS, okay? So I think you should not even set up a simple development environment, a test environment. You should not even set up those kinds of environments using the default VPC because it's basically open. It's an open network. Anybody can connect to your servers, so you should try and avoid using the default VPC once you become a little bit familiar with AWS and VPCs. All right. Okay. So this is broadly what we did in the previous module. We did speak very, very briefly about direct connect. This is basically a direct connection from your network to the AWS region, right? So you basically bypass the internet, right? You're not using the internet. You're connecting directly to AWS. It makes sense for maybe some larger companies where maybe you save some cost, right? A direct connection may be cheaper than using a regular internet service provider. Okay. Also, the performance will be more consistent because the nature of the internet traffic is such that the performance always changes depending on the network path that is being taken by your network packets. Okay, so that was direct connect. So this was a networking module. All right, so now let's talk about today's module. This is obviously on databases, right? And there are 4 database services available today under AWS. You can consider some other services also as databases. Say Hadoop. So there's a service called EMR, Elastic MapReduce, and there's also another service called Elasticsearch. Right, so those can also be considered databases of some sort. All right, but here we're not talking about those. We are talking about more, more traditional type of databases, right? But there are 4 different options here, and in this module we will cover all 4. Okay, because they're all important. They are all important. We can't, it would not be right to leave out any of these, right? So we'll talk about all 4. But we'll spend more time on some of the more commonly used, the more important services. All right. Now, RDS. The first one is RDS, a relational database service. This is the regular databases. Stuff that we've all probably used. Oracle, Microsoft SQL Server, MySQL, PostgreSQL, and so on. Right, so those kinds of databases. These are SQL databases, also called relational databases, right? So for those kinds of databases, there's a service called RDS, Relational Database Service. Okay, very, very important. So we'll spend most of our time on this, right? Or rather, we'll probably spend more than an hour, maybe. Right, so maybe 45 minutes, maybe 1 hour, 15 minutes, something like that on RDS. Okay, all right. The next service is DynamoDB, right? DynamoDB, and this is a NoSQL service. So you can create NoSQL databases, and we'll discuss the difference between relational databases and NoSQL databases. Okay, but it's a NoSQL database. NoSQL databases are usually good for very large-scale databases, and where you need very fast performance. Okay, so it's a newer technology. And there are some open source options available, and in AWS there's this DynamoDB, which is a proprietary technology. It's AWS's own service, right? So with RDS you can use Oracle, SQL Server, etc. Stuff that's available even outside of AWS, right? But DynamoDB is an AWS only service, right? So it's a little bit different from RDS. All right, we'll also talk about 2 others. Elasticache. This is an in-memory cache, right? In-memory would mean that the data is stored in the random access memory, RAM, in the RAM, right? So it's an in-memory, which means when you read the data from such databases, it's always very, very fast, right? Because when you're reading from RAM, it's much faster than reading from the disk. So this is Elasticache. It's good. You have to combine Elasticache with a regular database normally. Okay, so it has to be used along with the regular database, and it can be used to speed up the performance, improve the performance of your applications. It can also be it can be used to offload traffic away from the main database, so that the main database performs better and is not overloaded. Okay, so that's Elasticache. And then finally we have a Redshift, and this is a data warehousing solution. Okay, it's a data warehousing service, and it's a petabyte scale service, right? So you can have really serious data warehouses set up on Redshift. Okay, and by the way, Redshift is the fastest growing service in AWS today. Okay, so it's very, very popular. Okay, and probably because it's cheaper, it's pay-as-you-go pricing, and probably the industry and the customers are not very happy with the regular warehousing solutions that are available in the market. Okay, so these are the four database services that are available, and we'll talk about all four. Like I said, we'll spend more time on RDS because it's more important, right? Next, we'll spend a little more time on DynamoDB, and then the other two, Elasticache and Redshift, we'll try and finish in a shorter period, right? So maybe half an hour to 4 or 5 minutes for both of them, right? And the rest of the time will be divvied up between RDS and DynamoDB. Okay, now, first of all, right, the first thing I want to tell you about these database services is that you don't have to use them. Okay, you don't have to use them. It's not mandatory, right? For example, if you wanted to set up an application in AWS, you have to use EC2. Right, you have to use EC2. You have to use EBS. Often S3 makes a lot of sense. Right, there's no service like S3. Okay, VPC has to be used. All right, but these services need not be used. Okay, need not be used. Why? Because let's say you want to set up Oracle, right? You want to use Oracle as part of your stack. You can always run that database, Oracle database, on an EC2 instance. Right, because EC2 instances are servers like any other server, and you can install Oracle on an EC2 instance and do it that way. Okay, same thing with any other database. So MySQL, SQL Server. In the NoSQL space, you have options like MongoDB, Cassandra. Right, even in the caching space, you have options like Memcached and Redis. Right, you can also run some kind of data warehousing solution on EC2 instances, right? So all these database technologies that we're talking about, they are available either as a commercial product or as an open source product, right? And you can install them on an EC2 instance or on a bunch of EC2 instances, and you can do things that way, right? You can do things that way. Okay, so you don't have to use these database services because EC2 is always available. All right. Okay. So then, what's the point, right? You might be wondering then, what's the point? So the point of these services is that these services add value, right? So they do more than just providing the infrastructure. So EC2 is basically a very low-level infrastructural element, right? So it's just a server. It's just a virtual machine. You get the server, and then you can do whatever you want with the server. Install whatever software that you want, whatever database that you want, right? So EC2 is a low-level infrastructural element, and you have to sort of do the rest, right? So you have to do the heavy lifting to some extent. Whereas with these services, these database services, what happens is the services do much more than just providing the infrastructure, right? So they're not just servers, right? They're more. For example, RDS can do things like automated software updates, right? So your database software has to be updated, right? Every few months, maybe every few weeks, right? With security patches, minor revisions, major upgrades, right? So those kinds of things can be done by RDS automatically for you, right? RDS can also do automated backups. Okay, so it can do automated snapshots, so your data is safe. It can also be scaled it can also do replication, by the way, right? Scaling is something you have to do manually, but it can do master-slave type of replication, and along with that, you also have failover, right? So if there's a problem with the primary instance or the primary zone, right? Then the instance can fail over to a secondary database, in a secondary zone, right? And this failover is automatic, and also it is seamless, right? So you can see now that RDS does these things for you, right? And therefore it becomes a choice, right? Do you want to set up your database on EC2 instances and manage things that way, right? Or you want to sort of hand over things to RDS so that you can focus more on your application, right? Not worry too much about the infrastructure side, the administration side, the DB administration side, right? So all those things can be handed over to AWS or RDS, and you can just focus on your application, right? So it's a choice. You have to decide, right? You have to decide. So when you do things on EC2 yourself, right, you have to do most of the things, right? So it's more effort on your side, but you have more control, right? You can control every aspect of your stack. You can choose the operating system, you can choose what database software, what version of the database software, right? All those things you have control over. You can also tune the database better, right? You can tune things on the OS side. So you have more control when you do things on EC2 yourself, right? However, the downside is you need to have the expertise, right? You need to spend a lot of you need to put in the effort, right, to manage your database, etc. So those things are not required when you use something like RDS. Okay, so it's a choice, and as a solutions architect, right, you have to think about these things, and you have to make the choice for your organization. Okay, so it's very important to understand that these are not mandatory, right? You don't have to use this. You can always use EC2 instances. Okay, so these are the four services, right? These are the four services. We have discussed this a bit, right? But you can see here, RDS is the relational database, right? This is the more traditional databases, Oracle, SQL Server, etc. Right? DynamoDB is NoSQL. It's NoSQL. NoSQL technology, again, it's not an AWS invention, right? NoSQL has been there for a while now. Of course, it's much newer compared to the traditional databases, the traditional relational databases, right? But NoSQL technology has emerged in the recent past, right? And it's not an AWS invention. But DynamoDB is a proprietary NoSQL technology from AWS. Okay, you do have some other options. For example, there are two popular NoSQL open source technologies, right? So there's MongoDB and there is Cassandra, right? So these two open source database engines are popular, and DynamoDB would be a competitor, right? So DynamoDB is a competitor to MongoDB and Cassandra. And but if you prefer MongoDB or Cassandra, you have to sort of install those on EC2 instances and run them that way. Okay, so with DynamoDB, there's a choice. There's a choice between using open source, open technology on EC2 instances, or using this one, DynamoDB, which is more proprietary, right? So there's a bit of a lock-in here. If you use DynamoDB, you get locked into AWS. Okay, so that's a choice there. All right, and then Redshift is warehouses, data warehouses. These are typically very large databases, very large amount of number of records, very large number of columns as well, because often warehouses have data from multiple applications, right? And the amount of data is large because it's cumulative data, right? Data accumulated over a long period. Right, so that's a typical data warehouse, and because the data sizes are so large, the regular database technologies, regular SQL relational databases will not be sufficient, or not sufficient, right? So you need something special. You need something designed for warehouses, right? And that's what Redshift is. Okay, so it uses something called MPP. Massively parallel processing, right? So it breaks up your query into multiple pieces, and each piece of that query is processed by an individual server, right? So you normally have a cluster. It's not a single server. You have to have a cluster of servers, and they execute the query in parallel, right? So that's why Redshift can handle very large amounts of data. All right. Okay. And then finally, we have Elasticache, right? And this is, like I said, in memory. It's an in-memory database, right? So in-memory databases are always faster. Okay. It's just the nature of things, right? So when you read from memory, it's always faster than when you read from the disk, from the storage, right? So Elasticache or in-memory caches are often used along with regular databases to speed up the application, right? Improve the application performance. It is used normally to store pieces of data which are frequently requested, right? If they're frequently requested and they're requested by lots of users, right? Then it becomes a candidate for being stored in a in-memory cache. Okay, so this can be very helpful. An Elasticache type of service can be very helpful, both from a performance point of view and also from a cost point of view, by the way, because you can offload traffic, right? You can remove traffic from your main database, which means the performance of your main database improves. Also, you don't need big servers, right? You don't need too much capacity on your database side, because a lot of the traffic will be offloaded to the cache. All right. Okay. So these are the four technologies. Now, a quick mention about something called Amazon Aurora. Okay. So this is a part of the RDS service. It's not a separate service, part of the RDS service. And what this is it's a custom MySQL compatible, a MySQL-like database engine. Okay. And it's compatible. It's compatible to MySQL. So if your application uses MySQL, it will work with Aurora. All right. But what they've done is they basically customized MySQL, it looks like, to work better with their hardware. Right. So they've done some optimization where you get much better performance for the dollar. Right. So for the same server size, you get much more 5x performance with Aurora than you would with the regular MySQL. Okay. And recently they've also announced the availability of Aurora for PostgreSQL as well. Okay, so these are the four database technologies. Now let's start, right? So let's start. What we'll do is as far as Q&A is concerned, we'll use this new sheet. Okay, Mod 5 databases. If you don't have the link to the document, please let me know. Okay, so let's start with RDS. Okay, that question was more about DynamoDB, so we'll come back to that. Let's start with RDS, and like I said, we'll spend most of our time, right, or well, not most, but a lot of time on RDS. Okay, so RDS is a relational database, right? Relational databases are the regular databases, Oracle, SQL Server, MySQL, etc. Right? Why are they called relational databases? Because you can have relationships between tables, right? So you have foreign keys, right? You can have foreign keys, and when you're querying, you can join, right? You can use joins. So you can say something like select, so and so from one table, from table A, table B, join on, so and so columns, right? So you can join tables. So because of this, these foreign keys and these joins, the technology is called relational databases, right? But it's the usual database. This technology has been around for a while, right? And what RDS does is basically it lets you create and manage databases, relational databases on the cloud in a very, very simple manner, right? So RDS is actually, you can think of RDS as a platform and not an infrastructural element, right? It's not infrastructure as a service. It's more like a platform as a service, because it doesn't just give you server capacity. It gives you much more. Okay, it gives you much more. All right. So as you can see here, you can easily start up, one database or many databases, right, in the cloud, very similar to EC2. Actually, RDS is built on top of EC2. Okay, so it's EC2 instances plus the database software plus some automation, things like Um, my apologies, folks. Just give me a second. There's some background noise. All right, my apologies, folks. There was a little bit of background noise in the neighborhood. All right, so I hope it's better now. Okay, so this is what RDS is, right? It helps you create databases on the cloud in a very simple manner, right? And it's easy to plus database software plus automation. Okay, that's what it is. So you don't need DBAs, right, to the same extent. And you do need DBAs for things like query optimization and advanced database stuff, right? But the low-level stuff, things like patches, backup, replication, right? All those things have been automated away, right? They've been automated, so it becomes much easier, right? Before this, if you had to run a serious database, you would need DBAs, right? And those things then it becomes less democratic, right? Only the larger companies can do these kinds of things, right? But now it becomes much simpler, right? It becomes more accessible. So any small company, any startup as well, right? Without serious DBA type of skills, without serious system admin type of skills, you can easily set up and run databases, large databases on the cloud. Okay, right. So that's what RDS is. Okay, so now it supports, it's not proprietary, right? You can see here, it's not a proprietary AWS technology, right? These are standard databases, right? Database technologies which are used anyways, right? They've always been used well before AWS came on the scene, right? So RDS basically supports, the popular database engines, right? What it has done here, what AWS has done here is simply to marry the database engines with its EC2 infrastructure, right? So that's what it is. So here you can see the support is available for the most popular databases, right? Database engines. So you have Oracle, you have SQL Server, which is more for the enterprise market, and then you have MySQL and PostgreSQL, which is I guess startup and small companies, right, and increasingly enterprises as well, right? And then you have MariaDB, which is the newer. It's a fork of MySQL, right? And because MySQL got acquired by Oracle, so it's not. It's still open source, but it's not considered. Community, right? It's not considered to be in the control of the community. So there's MariaDB, which is basically a fork of MySQL. So all these database technologies are supported, right? So you can use whatever you are already using for your applications. All right. And then you have Aurora, which is a custom MySQL and also custom Postgre technology that is available. Okay, so now the benefits, right? So why should we use RDS? And remember, once again, right, you can run these databases on EC2 yourself. Okay, so there has to be a good reason, right, for using RDS. And the benefits are, some of the benefits are, basically the main one is the administration, right? It's easy to administer. So you can, create a Oracle server, a server with Oracle installed on it very, very quickly, a matter of minutes. And then it has automated patching, automated backups. You can have replication, right? So all these things, if you try to do yourself, it would be quite a task, right? And also the ongoing maintenance, right? The ongoing maintenance of it. For example, just taking care of backups is a big job. Taking care of replication, making sure it always functions, right? Taking care of failovers, all those things require serious expertise, right? But here you don't have to do all that because RDS does all of that in a fully automated fashion. Okay, so the ease of administration is the biggest plus point, right? You don't have to worry about DBs, you just use them, right? You become a user, you don't have to really manage the database technology. All right. Okay. Scaling, right? Scaling normally, with databases especially, you don't do horizontal scaling, right? It has to be scaled up or down, which means you can go from a smaller server to a larger server, right? Or you can go in the other direction as well. But scaling is pretty easy, right? So just like with EC2 instances, with EC2 instances, if you remember, we must have discussed, you can easily go from, say, a small server to a 4x large or a 10x large server, right? So you can easily change the server size or type, and the same thing is available with RDS as well, right? So it's very easy to scale, only vertically though, because the nature of the database technology is such that you don't do horizontal scaling here, right? You simply do vertical scaling, but vertical scaling is very simple. You simply have to say, okay, now I have a small server and I just want to change it to something else, right? You can change the server size very easily. Okay, as far as availability and durability is concerned, you have the option of high availability with RDS, because you can do replication, right? So you can create a master server and a slave server, or a primary site, essentially a primary database and a secondary standby database, right? And then there's replication, which is done automatically for you, and also the failover, right? So if the primary fails, it fails over. RDS will fail over to the secondary site seamlessly, automatically, right? So you don't even have to change your application, so in that sense, it is highly available as well, right? It's an option. You don't have to have replication, okay, because it costs more. But if you do have replication turned on, then you have the use of multiple availability zones, automated failover, secondary site, right? So all this will give you high availability. Okay, and durability is data durability, right? How safe is your data? So RDS uses EBS. Okay, so EBS is good. EBS is much better, 20 times better than traditional hard disks, right? So you have the EBS service levels with RDS, right? And then in addition to that, you have the automated backup, right? So that gives you additional security. You can also have replication, like we discussed earlier. So that gives you additional data security as well. You can create read replicas, which can sort of spread the data to multiple instances. Right? So there are many ways of protecting your data, basically by creating many copies of your data. Okay, so all those options are available. That's why you have high availability and high durability as well. Okay. All right, so these are the major advantages. You can review the documentation for some of the other benefits as well. Okay, now let's talk about the implementation side, right? So first of all, what you have to know is when you use RDS, you have to create a DB instance, right? Very similar to how you create an EC2 instance, right? So you have to create a DB instance. A DB instance is a server, right? And on that server, you have your database engine installed. So Oracle, you have to choose, you have to pick one, right? You can't have multiple database engines on the same server, right? One server will have only Oracle or SQL Server or MySQL, okay? So one server has the database engine installed on it, right? So that's called a DB instance. You can have many DB instances as well, right? And in each DB instance, you can have multiple databases, right? So a lot of people confuse this, right? They think that one instance is one database. No, one instance is a server, right? That server has the database engine, right? Your Oracle server or your MySQL server, right? And in that server, MySQL server or Oracle server, you can have multiple databases, okay? So in that sense, it's very much like a regular server with a database server installed on it. All right. Okay. Now, as far as the limitation is concerned, you have the maximum size of your RDS storage is 6 TB. Okay, 6 terabytes is the maximum size that's available to an instance. Okay, so what this means is if you have a database larger than this, right? Most people don't need more than this, right? But if you have a very large database, larger than 6 terabytes, then you cannot use RDS, right? You can't use RDS. So then you have to go back to EC2. You have to run your databases on EC2 and manage it yourself. Okay, so this is I don't know. I'm not sure why this constraint is there, but right now this is a limit that applies to RDS. Okay. Also, remember, we said that RDS is built on top of EC2, right? So the server sizes and the types of servers you can see here, it looks familiar, right? So you have M4 type, you have R3 type. So these are basically, some form of EC2 instances, right? With their sort of unique characteristics. Okay, so that's what it is. It's basically EC2 instances, different types. Right, and on each on different types, you can have different database engines for your, you can choose from all these database engines, right? So that's how it is set up. Now, also you have the same sizes available as well, right? So you have micro, small instances, medium, large, and so on, going up to 10x large. Right, so you have various sizes available. You can pick whatever suits your needs, and of course you can also change quite easily, right, from one type to the other. All right, now as far as pricing is concerned, the price will vary, first of all, based on the size of the server, right? It almost changes linearly. So a micro will have the least price, right, and then it'll keep increasing. 10x large will have the highest price, right? So this is the hourly price. Very similar. It's very similar to EC2, right? So these prices are instance hour prices. All right. The price will also vary by the software, right? So because remember, some of these are open source technologies, which are basically free of cost, right? And also some of these are commercial products, so there'll be a software cost, right? So the software cost is included in your hourly price, right? So you can see here for Oracle, the micro instance costs 4 cents per hour, right? So part of that money will go to Oracle, right? So Oracle and AWS will have an arrangement where AWS will share some of that money with Oracle, right? Towards the cost of software licenses, okay? And the rest of it will go to AWS for the infrastructure, okay? So this is how it works. The hourly price will include both hardware and software cost. Okay, so Oracle will be the most expensive, right? Because it's the premier database engine. Then you have SQL Server, which will be somewhere in the middle, and then the open source varieties will be the cheapest options. Okay, all right. You also have memory optimized, the same thing, same stuff. It's very similar to EC2. So you have standard general purpose servers, and you have memory optimized servers, right? So the same thing applies to databases as well. It depends on your use case, right? Depends on the kind of stack you have, the kind of application you have, what you do at the database layer, right? So it depends on your needs, which type of server you will choose, what size you will choose. All that is up to you, right? And it depends on your understanding of your own application. Okay, all right. Now I think one more point here, and then we'll maybe do a demonstration. So one more thing that you have to know is that there is this option called multi-AZ, right? Multi-AZ deployment. All right. And what this is it's basically the replication, right? So you have a primary server or the master server, and then you have a slave server or the secondary server. All right, and there's replication from the master to the slave. Right, and always the secondary server is in a secondary zone. Okay, so both servers are in two different zones, always. Okay, so that's how RDS does it. It creates a secondary site in a secondary zone. Okay, this is important because, as you know, zones are independent, right? So they have independent power supply, internet connection, and so on. If there's a problem, only one zone will be affected, right? So if your primary is affected, RDS will fail over to the secondary site, which is in a separate zone, right? So even if the primary zone has failed, your database will still be available. All right, okay, so that's multi-AZ deployment. You don't have to use it, it's an option, right? So for example, for a test environment, you don't need multi-AZ, right? But for a live environment, a serious application, you should think about using multi-AZ deployments. All right. Okay. So now let's take a look at RDS. Right. I'm going to show you a short demonstration. I'll show you how to create an RDS instance, and also we'll try and connect to the RDS instance. Okay. And then we'll also take a we'll basically inspect the various actions that are available with an RDS instance. For example, how do we take snapshots? How do we create read replicas, and so on. Okay, so we'll spend a bit of time on the web console looking at an RDS instance and seeing what are the various features that are available. Okay, but first we need to launch an RDS instance and also try and connect to the instance. Okay, so let's go from the home page. Let's find this database category, right? And you can see the 4 options are available under this category, right? Now let me click on RDS. Okay, so let's go ahead, right? We'll worry about these options later, but let's get started right away. And this is the first step, right? It's the first step to creating an RDS instance. And the first step is obviously to pick one of these engines, right? So you can pick whatever you prefer, right? Whatever you use currently. Every company has a preference, right? So one company normally uses only one database technology. You can pick whatever is the most appropriate for you. All right, so I'm going to pick MySQL. Right, I'm going to pick MySQL. By the way, this is free tier eligible. I think every service is free tier eligible as well, right? So it's not like only MySQL is available, right? Aurora is not. Aurora is not available under the free tier. Okay, so that's why when you're starting off, it's better to use something like MySQL. All right, so let's pick this one. Okay, the next step is to pick what type of environment you want, right? So we'll go with the dev test type, where we have a single instance, right? We don't have the primary, secondary replication type of thing. So we just have a single instance. Let's go with this one for the moment. All right. Okay. Now here, this is the next step, and we have to sort of configure our database, right? So our instance rather. So here you will do things like, maybe you want to choose the MySQL version, right? Maybe your application is a little older. It is only certified and tested with MySQL 5.5, right? Maybe something like that. So you can change this if you like. But remember, you don't have all the versions, right? Your application may be so old that it uses a very old version of MySQL. I don't know, maybe MySQL 4 or something, right? So that's not available with RDS. If you need something like that, you have to go back to EC2 and run your own database. All right, so this is something you can do. You can also select the server size, right? So this is the whole spectrum is available to you. T2 type, M4 type, R3 type, right? So all these options are available. They differ in the performance characteristics, right? The T types are more for bursty traffic. M types are more for stable workloads, right? And then R, I think, is a memory optimized type of instance. So you can pick what you think is the best, right? And also the size, how much CPU and how much of a RAM you think you will need. Okay, so let's go with micro, because micro is covered under the free tier. All right, we're also going to say no to this one for the moment. This is not going to be a multi-AZ deployment. All right, now storage, right? So remember, in our EBS discussion, we saw that EBS has actually 5 types, right? Here we have 3 types, SSD, 2 SSD types. General purpose is fine, right? You should start with this, but for more performance for live environments, you can go with provisioned IOPS, right? Magnetic is very slow. So I don't think you should be using Magnetic with RDS, right? But it's available as an option for maybe some kind of database which is hardly used, right? Some kind of application which has very low usage. Maybe there you can use Magnetic. This is cheaper, right? This is a cheaper option, all right? But we'll stick with general purpose here. Now, based on these 2 fields, the server size and the storage type, right? This is EBS, obviously. You can now see, right? You can make out that RDS is actually built on top of EC2 instances. All right. Okay. Now this is the allocated storage, the amount of storage available for your database, right? So this has to be, you have to carefully choose this option, right? Because you don't want something too large, because then your cost will be higher, right? So your cost of storage with this instance will be high, and then you'll have to take snapshots, right? Databases especially have to be snapshotted on a regular basis, right? Nightly basis is what most people do. So your snapshots will also become too big if your storage is big, right? So be careful. Don't pick something too big for this storage. Also, you should not pick something too small, right? It should be appropriate based on your expectation, of the size of your database, right? And also the growth of your the rate of growth of your of the database size, right? Because remember, if your database engine or server runs out of storage, the database simply stops functioning, right? It basically stops functioning. You might have seen this with as part of your projects, right? I've seen this database. The server runs out of space. The database simply stops responding, right? So you have to be careful. It should not be less as well. Okay, so this is an important field. You have to monitor this carefully over time and keep changing it, right? You have to keep changing it as your database grows. All right. Okay, so next is just a few other things. So this is our let's say our database identifier, unique identifier of your database, because you can have many database instances, right? So this is an identifier of the instance, and then this one is the root user. All right, the root user of your uh, of your of your RDS instance. So it is like a database, the root user of your database server. Okay. All right. So let's set up the root user and click on the next step. All right. Now here, I think just this one more page, right? This page here, and then we are done. So here, you have to specify the network side of things, right? Now that we are familiar with the VPCs, what you can do here is you can select your VPC, right? You can select your VPC. Now this VPC is, by the way, the default VPC, the one that is not very secure. Okay, so right now we just have this one, but you should practice later by creating your own VPC, maybe a scenario 2 VPC, right? So create that and select that here. Right? But right now I'm selecting the default VPC. All right. Okay. One more thing that you need to know about RDS and VPCs is that RDS instance needs 2 subnets. Okay, at least. So it needs 2 subnets, and normally you'll have RDS in a private subnet, right? So, for RDS, you need to have 2 private subnets. All right. So when we use the VPC wizard, we normally have, in scenario 2, we have 1 public and 1 private subnet, right? But RDS needs 2 private subnets. Okay. So you have to first create a second private subnet after you've created your scenario 2 VPC. You have to manually create another private subnet. Okay. Then you're ready to launch your RDS instance. All right. So we'll see, if you have time, we'll see how to do all that, right? Especially maybe we can talk about it maybe in a weekly review session, some extra time that we have, or we can talk about it in module 10 where we have an open session. Okay, but that's a very important point, that for RDS you need to have at least 2 private subnets. Okay, and it needs 2 private subnets because for that primary and secondary instances, right? Because maybe later you may, even though now you have a single server, later you may have a primary secondary set. So for that you need to have 2 subnets in 2 different zones. All right. Okay. So for now we are sticking to a default VPC. That is not very secure, but it's simple. So let's do this today. Okay. Now also you should normally say no to this. Right? The RDS instance should not be publicly accessible. Right? That doesn't make sense. Nobody needs to connect to your RDS instance directly, right? Your web servers, yes, they have to be publicly accessible, but RDS instances normally should not be publicly accessible. Okay, but today in this demonstration, we're not worrying so much about security, right? We're trying to make sure that we get the RDS instance up and we're able to connect to it. So let's keep this at yes. All right. Okay, and then the security group, right? So your RDS instance also needs a security group, very similar to how an EC2 instance needs a security group, right? And you should create a database server security group, right? So yesterday we created this one, my app, or well, okay, in one of the earlier demonstrations we created this one, right? My app, it's a web server security group. All right, so you have to create a security group for your databases, right? And the rules of those of that security group have to be carefully constructed to allow incoming traffic only from your app servers, right? So that kind of security group you have to create. We'll again talk about that a little later, right? I'm just trying to tell you how you should do this, right? Maybe you can think about this, maybe practice this a bit, and we can discuss it at some point. Today, let's keep things simple. So what I'm going to do is I'm going to choose the default security group. This is very open. Okay, it allows all incoming traffic, right? So right now the security group is very weak as well. All right. Okay, so now we have this RDS instance coming up in the default VPC with the default security group, right? And it's publicly accessible for the moment, right? This is not good practice, right? But for I'm just showing you this because when you first launch your instance, right? Your first RDS instance, you should not have too much trouble connecting to it, right? So that's why I'm trying to make things simple from a networking point of view, right? That's why we are doing this. But when you for your real environments, you should not be doing something like this. All right. Okay, so that's your network side, and then let's say we have a database here, say MyDB, right? Remember, in this RDS instance, we can have many databases, right? So this is just one of the databases. You can have many, all right? This causes confusion because people think you can only have one database in this instance, right? That's not true. This is just one of the, maybe the first one, right? So we'll define this here. All right. Okay, and then a few more things. So you have backup, right? You have automated backup, and you can define how long the backup should be retained for. It's by default, it's 7 days. So each backup is retained for 7 days from the date of its creation, right? And the maximum backup retention period is 35 days, right? You can also set it to 0, which means there's no automated backup. All right, this is used in some cases. I'll explain all this later. Okay. Also, you can have automated patches, right? So you can say, for example, minor versions. Do you want the upgrades to happen automatically, right? So you can choose a yes or no on that. The major upgrades, you have control. You have to decide when you want to upgrade. When there's a major upgrade, right? But minor versions can be upgraded automatically. All right. Okay. So now let's launch this database instance. Right. So let's wait for this to come up. It takes a bit more time. So EC2 normally comes up very fast, but RDS it needs a few minutes. Right. Maybe 2 or 3 or 4 minutes, something like that is what is required for the RDS instance to come up. All right. And maybe this is because there's some provisioning and then there's some software work as well. So it takes a bit of time to right. So once this comes up, we'll sort of inspect this server. We'll take a look at what are the various options available with this instance. Okay, so that's coming up. Let's wait for this server to come up. Also, of course, very important, we have to see how to connect to this server. Okay, we have to learn how to connect to this server, and also you have to see that you connect using a database client, right? There's no server here. You don't SSH or RDP, right? You don't SSH or RDP to the server and then log into your database. You have to connect directly to the database. Okay, so the connection bit will be important, but for that we need the server to be up. All right. So while this is coming up, let's do a bit of Q&A on RDS specifically, but also some of the introduction, right, where we spoke about the 4 database services. You might have questions on why do we need 4 services? What are the major differences between those? Right. So those kinds of questions, let's discuss. All right. Okay. So let's go through these questions here. So first one, Babita, DynamoDB, where is it installed? So Okay, so if you have Cassandra on EC2, how is it different from DynamoDB? Yeah, so both are NoSQL technologies, right? So both are NoSQL. Okay, so they're both NoSQL. So it's the same technology, right? And NoSQL we'll discuss more, when to use it. So let's leave that aside for the moment. Let's say you need NoSQL, right? And the option in front of you is should I do a MongoDB or Cassandra on EC2, or should I use DynamoDB, right? So what's the difference, and what are the pros and cons of both? Okay, so the two choices you have, two options you have. One is MongoDB or Cassandra, right? On MongoDB or Cassandra on EC2. That's choice number one, right? Choice number two is DynamoDB. Right? Both are NoSQL. You can use either one. So the pros here are you have full control over your databases, right? You can manage everything. You know, the OS level, the tuning, the performance tuning, the backup, everything is under your control, right? And also the other pro is that this is open technology. Right? So you're not locked in. You're not locked in to something proprietary, right? So this is open technology. All right. The cons here are you have to do the heavy lifting, right? You have to do the heavy lifting of managing the database, right? So things like backup, maybe performance tuning, right? The installation itself, right? Installation, upgrades, security patches, all these things you have to do, right? Okay, all right. Now DynamoDB is a proprietary NoSQL technology from AWS, right? The pros are it is quite simple. It's quite simple to use, to set up and use, right? It scales very well. It scales very well. Okay, and also it's it has many copies of the data, so the data protection is better. Data durability probably is better. Okay, so it's a true cloud service. It's similar to S3 in that sense, that it's been created on the cloud for the cloud, right? So it scales much better. And it's very simple to use. You don't have to worry so much, right? You don't have to worry about it. The administration, right? The admin is very simple. Right? Basically, there's no admin, there's no backup, there's no security patches, nothing. You don't have to do anything, right? The administration is very simple. The cons are it's proprietary, right? It's proprietary, so there is a bit of a lock-in here. If you use DynamoDB, you are locked in to AWS, right? You can't get out of AWS so easily because you're using DynamoDB. Okay, so what happens here is you connect to, or rather you use DynamoDB using the AWS API, right? And that makes it it's not an open standard, right? It's not like ODBC, JDBC, right? It's not an open standard, so you get locked in because it's a proprietary interface, it's a proprietary technology. Okay, so these are the pros and cons of this. All right, Chandra, how does AWS handle database updates and patches for the latest database releases from the vendor side? Oh, I mean, very similar to what you would do, right? So very similar to what any customer would do, right? So they have, AWS will have arrangements, right? Have arrangements with the database vendors, right? To access the updates and patches. Right, so very similar to what you would do as a customer. Let's say you're a bank, right? So you have a sort of a support contract, maintenance contract with Oracle, right? As part of that contract, Oracle makes sure that you have access to all the latest patches and updates, right? Same way they'll have some sort of arrangement with these vendors. All right, next question, Subhani. Initially, you configured RDS size 10 GB. If database size is crossed after some days, how to increase the size of the database in this case? Yeah. Now, so the size is of the storage, first of all, right? We're not talking about the server size, we're talking about the storage size, right? So right now it's 10 GB and you want to increase it, right? So very simple. Just modify the RDS instance, there's a menu option, right? Just modify the RDS instance and go and change the allocated storage to whatever value you want. It's very, very simple. Okay, but remember, this might lead to a server restart. Okay, so it should be done in a maintenance window. So so make sure the change happens in a maintenance window. Okay, but the change, changing the server allocated storage is very, very simple. Just go and edit, right? It's just an edit to your RDS instance configuration. All right. We are choosing automatic backup, the backup storing location. You don't have to worry so much about it, but it's basically S3. Okay, it's basically stored in S3, very similar to EBS snapshots, right? So these are RDS snapshots. They're also stored in S3, similar to EBS snapshots. All right. Okay. So while you're typing your questions, right? Let's take a look at our RDS instance. You can now see that it is in an available state, right? It's in an available state, which means we can start using this instance, right? This is great, by the way, right? Because there's no installation, no configuration, nothing like that, right? You just get the database server right away, and you can start connecting to it. Okay, so how do we connect, right? So you can see there's an endpoint. There's an endpoint that is available, right? There's no IP address. Remember, with EC2 instances, you have an IP address, right? Especially a public IP address is what you use to connect to the RDS, to the EC2 instance. Here, there is no IP address, right? You might want to think about why that is the case. Why do we not have an IP address here, right? So instead, what we have is a DNS endpoint, right? This is the DNS endpoint. So let me copy this. I'm going to copy this here, right? And now to connect. So this is my computer, right? So I'm connecting from my home network to the RDS instance. And the way you connect is like this. So you say MySQL. This is a MySQL instance, right? And you supply the -h option. This is -h is for host. So you have to sort of supply the IP address normally of the server, right? This is the port, and then you have the user, right? And then -p is for password, right? So basically, you want to use the password. So this is how you would connect, right, to any database server. This is nothing, not AWS specific, right? So whenever you want to connect to a MySQL database server, you have to, issue a command like this, right? So let's now supply the password. Okay, so that's it, right? So now you can see this is the MySQL prompt, and here you can run your MySQL commands, something like show databases, maybe, right? So this is your set of databases. You can also use your database. This is the database we created when we launched the instance, right? You can do show tables to see what tables are there. Obviously, right now there's no tables because we've not created any tables, right? But you can go ahead and create a table, and essentially all your usual MySQL commands will function. Okay, but the main thing to note here is, let me exit this session, right? Let me exit the MySQL prompt, and now I'm out of RDS and back to my own computer. Okay, so you can see we are connecting directly to the database engine. We're not doing an SSH, right? We're not going to the server. We're not doing an RDP. We're not doing an SSH, right? You don't have access to the operating system. Okay, so don't think of an RDS instance as a EC2 instance in that you connect to the operating system. Okay, you connect directly to the database engine using a database client. So in the case of MySQL, you use a MySQL client, right? In the case of a PostgreSQL engine, you will use a PostgreSQL client, right? Same thing with Oracle and other database engines. All right, so this is one. This is how you connect. Now remember, we made this RDS instance a publicly accessible server, right? Normally you will not have that. Okay, so normally it will be a privately accessible server. So in that case, this endpoint will be a private endpoint, right? And it won't be, you won't be able to connect to it because it's a private endpoint. All right. Also, normally an RDS instance will be in a private subnet. So anyways, you'll not be able to connect from the outside the way we have done today, right? You can only connect to an RDS instance from within the VPC. Okay. So all those things you should think about. We can discuss it at some point. All right. Okay. Now this is your server, right? We've seen how to connect to it. Now let's talk about a few other important features. All right. So here, if you look at the instance actions, right, you can see there are multiple actions here. For example, you can take a snapshot, right? So this is very similar to an EBS snapshot. You can create a manual snapshot, right? So let's say my RDS snap, right? You can create a snapshot of your RDS instance, and a snapshot is basically a point-in-time image of your RDS server, right? So all the data in the RDS instance at that time will be snapshotted, right, and it will be saved. Okay, so this manual snapshot is in addition to the automated snapshot that we have already set up. Okay, you might want to think about why, right? Why do we have automated snapshot and why do we have manual snapshot, right? Do we need both? Okay, you should think about that, and maybe we can talk about it at some point. All right. Okay. You can also, you can also create a read replica. You can create a read replica, right? So this is basically another server. It's another server. Okay. So let me call it my RDS read replica. Okay. It's another server, and this can be in the same region or it can be also in a different region. Okay. It's very important. It's a very important feature. For example, if you choose another region, this replica can become some sort of a disaster recovery solution for you. All right. So you can have it in another region or in the same region. You can have it in the same zone or in a different zone. Right. All those things are possible. Okay. And this is what a read replica is. Right. So it's a read-only database. You can't use it for for writing. Okay. You have to write into the primary database, but you can definitely use a read replica for read purposes. Okay, so this gives you the read replica gives you the ability to horizontally scale your database to some extent. Right, you can basically scale horizontally scale the read side of things. Okay, and this is very good because you can offload the traffic to the replicas, read replicas, right? Some of the read traffic, and your main database will be not be overloaded. Right, it will continue to perform well for the write requests. Okay, so read replica is that kind of solution. You can have as many replicas as you want, and of course, if you have it in a different region, then you also have some kind of a disaster recovery solution because the read replica can be converted into a read-write database. Right. So let's say your main region has some major outage, right? But fortunately, you have a read replica in a different region. So you can convert that read replica into a read-write database, right? It's called promoting, right? You can promote a read replica to become a full-scale database, read-write database, and then you can set up your application servers in that second region, and you're up, right? You're up. You have a disaster recovery site in a matter of minutes with the latest data available as well. Okay, so read replica is a very important feature. It has many use cases. All right. So that's the second bit, right? So we have seen manual snapshots, we've seen read replica, right? Okay, and there's also something called restore to point in time, right? Restore to point in time. So this is, restore to point in time is usually available with the database software, right? So let's say you do some upgrade, something goes wrong, your data has, been deleted accidentally or has been modified, something has gone wrong horribly, right? So you want to go back to a certain point in time when things were saner, right? So that point in time could be 1 hour back, half an hour back, right? Or a day back, whatever it is, right? Within the retention period, okay? Within the retention period, you can do a point in time restore. So you can say, okay, take me back to a certain point in time, right? So it could be, say today at a certain time, right? So maybe say 9:30 or something like that, right? So you can say something like this, and you can create a restore point in time restore. Okay, so this is another database that we're creating with the database as of the way it was at a certain point in time. All right, so this is how you can do a point in time restore as well. I'm not going to create that, but it's very simple to set up. All right. Okay. Now, finally, one more thing let me show you is that you can modify. Now, it's in a modifying state, so I'm not able to change it. But basically, you can modify your RDS configuration, right? And you can change things like the server size, the allocated storage, right? Whether you want multi-AZ deployment or not, right? So all those things can be easily changed by using the modify option. I'll come back to this option later. I think it's important to see it, right? But basically, you can modify all the various configurations of your RDS instance, right? Server size, storage size, what VPC, security group, right? All those things can be changed from the modify option. All right? Okay. Okay. One more thing, right? One more thing, and then we'll discuss this. So you can also do a reserved instance. And remember, we spoke about reserved instances, on-demand instances, when we spoke about EC2 instances, right? So reserved instances also can be purchased when it comes to RDS, right? And you can argue that reserved instances are more important for RDS because databases are usually run 24/7, right? The app servers, web servers, you can have, some of them can be removed, right? You don't need to run them all the time. Right, so they are so a database is especially an especially good use case for reserved instances, right? So you can save a lot of money. You can basically cut the cost by 60% and sometimes more if you use reserved instances. All right, okay, okay. Yeah, I think broadly this is these are the major features, right? These are the major features. I'm going to show you how to modify, right? How to modify the RDS instance a little later. But let's see if you have any further questions on RDS, right? Let's just focus on RDS. Let's see if you have any further questions. All right. Okay. So next question, Rao. What if you want databases like DB2, which is not part of RDS engine? Yeah. So you can't, right? So RDS cannot be used, right? Cannot be used. I don't think even EC2 supports DB2, right? So I don't think you can set up DB2 on EC2, right? As well. So you're out of luck as far as those kinds of technologies are concerned. You don't even have, you can't have mainframes, right? No mainframe technology, no Unix as well, right? All these things are not there, right? So they're just focusing on what is the most widely used stuff, right? And also, I don't know about DB2. If they have a deal with IBM, IBM can make it available, I guess. I don't know, right? And also, IBM is a competitor, right? So IBM probably wants to maintain everything in a closed sort of stack, right? So maybe there are those kinds of reasons as well, right? They may not be a technical reason, but there could be some competitive type of reasons as well. Okay, next is this one, Gajendra. By choosing the default security group, it won't work with Windows Server due to lack of RDP port. No, it should. It should because the default security group allows all ports, right? Allows requests on all ports. Okay, you can go and check the security group. It will allow requests on all ports, all protocols. All right. Also, unrestricted source IP. Okay, so because of this, it should work. It should work. All right. Okay. Next question. I do not have MySQL on my home Windows PC. How do I install MySQL on my PC? Oh, MySQL client, you mean, right? So you mean MySQL client, right? MySQL client. So you can download and install a MySQL client, I think, on Windows, right? So you should be able to download download a free MySQL client. Okay, you should be able to do it. Let's see. Right, so it's a MySQL client, right? You don't want a server because the server is on RDS, right? You want a MySQL client. So yeah, so there's something called MySQL Workbench, right? This is one, and yeah, there's some GUI tools, right? Also, things like PHP, MyAdmin, those kinds of things can be used as well, right? So let's see this one. Yeah, so it looks like Workbench, right? This one is the best one, I would say, right? MySQL has a client called Workbench, MySQL Workbench, right? So you can see here it's available for Windows, right? It's available for Windows. Okay, so you can do that. Alternatively, you can also create an EC2 instance, right? And from there, from the EC2 instance, you can try and connect to the RDS instance. All right. Okay. How do we connect from Windows? Yeah. So I think we've discussed that above, right? See above, right? All right. Next question. A snapshot will be created from the beginning or from the time we started. No. It's a snapshot, right? A snapshot means as of that time, right? So whatever data is there, whatever the state of the database, in terms of, say, database structure, what tables you have, right? And also what data you have, as of that time, the snapshot will be taken. Okay, so it's a point in time snapshot of your database. Okay, next question, Shyam, restore point in time. How does the restore work? At what frequency if the snapshot is taken to achieve this? What frequency is the snapshot taken to achieve this? No. So look, restore point in time is not, again, anything new here, right? So restore point in time has always been there with, say, Oracle, MySQL, etc. Right? So the way it works is you use a latest snapshot, all right? Plus you use the binary logs, right? Binary logs. So binary logs contain each transaction, right? It's a log file containing each transaction, each insert, each update, right? So the log files are also stored, okay, which have the latest transactions, and then you have the latest snapshot, which could be, say, 12 hours back or something like that, right? So you combine the two, and then you have a restore point in time, right? So the binary logs are replayed up to that point in time, right? So the way it works is start with latest snapshot, right? Say 12 hours back, right? And then replay the binary logs until the point in time, right? Until the restore point in time. Okay, so this is how, and this is nothing new, right? Nothing new here. It's the same. Nothing new here. Nothing new here. Okay, it's the same. It is the same old DB technology. All right. Okay, and what frequency is the snapshot taken to achieve this? Nothing. Nothing new. It's nightly automated snapshot. Once a day. Okay, once a day. All right. Next question, Sham. Suppose your RDS is in the VPC, which means it cannot be accessed directly from the outside. So if there's an issue with the database, how can a DB access and troubleshoot? Yeah. So you need, there are multiple ways of doing it. One is you can have a VPN connection. Right? You can create a VPN connection to the private subnet. Right. This is one way. The other way is you can jump. I think yesterday someone mentioned the jump server, right? So you can SSH to a server in the public subnet, right? And from there connect to the to the RDS instance. Right? Okay. So these are, I think, the two options. Okay, what's the default username in Windows DB Server and Oracle DB Server? Windows DB Server. There's no Windows DB Server here, right? So there's no Windows DB. Maybe you mean MySQL Server. I'm sorry, the Microsoft SQL Server. Maybe that's what you mean. So, okay, so there's no, right? So I'm just saying this because I just want to be clear. There's no Windows here because we don't know what operating system they are using, right? We just connect to the database. We don't connect to the operating system. So there is no Windows OS. Okay, MS Server. Okay, so what's the default username? I'm not sure. Let's check. Let's check. Let's say SQL Server. I think you can create it. You know, you can create it the way we did for this one. Okay, so so you can create it whatever you want. Yeah. So I think you can check it, but my guess is that you can create it. Right? You can specify this. You specify this when launching the RDS instance. So remember, in this demo that we just saw, right, we created the username, right, the root username and password. So I think it'll be the same one here as well. You can specify it. Okay, web read replica means creating high availability in some other region. No, it's you know, it can be a high availability solution, right? But that's separate. That's a separate matter. Read replica is a copy. Okay, it's a read only database instance. Okay, and there's replication of data from the primary instance to the read replica. Right, so it has your data, right, and it has the latest data as well. Okay, and this is asynchronous replication, by the way, right? So there may be a little bit of lag, but you know, it has all your data, and you can then run read queries on this instance, right? So it's not a backup though, right? It's like a backup. You can say it's like a backup because, you know, it's a copy of your data, right? But it's not just a backup; it's a real server. All right, so it's not just a backup. It is a real server, right, that can serve read requests. All right, so it's not just a backup. It's more than that, because you can, you know, offload your read in an application. Your read request can go to read replicas, right, and the write request can go to your primary database. Right? So you can create primary database with multiple read replicas, right? So it's more than a backup. All right, and I think we'll stop here, right? This will be the last question for RDS. We'll have to move on. We'll go to DynamoDB next, but let me answer this question. So to make our websites faster, yeah. So I guess what you're saying is, I mean, so you can create a master slave without much configuration, right? I think that's your question. So yes, I mean, the configuration. So it's called the multi-AZ deployment, right? Multi-AZ deployment option, right? Is simple to set up, right? Simple to set up. So by the way, let's take a look at that. Right, it's very simple to set up. So all you have to do is from here, right? You can say modify, right? Modify this RDS instance, and then you can change. You can change, say, multi-AZ to yes, right? You just have to say this, and it'll become a master slave with replication, right? That's all you have to do. There's no configuration that you have to do in your database side, right? So no configuration required, right? Okay, now by the way, when you modify, you can also change these things, right? You can change your server type, you can change your allocated storage, say from 5 GB to 10 GB, right? You can change your VPC. All those things can be changed when you modify your RDS configuration. Right? You can also change your backup retention period, right? The main thing to note, however, an important step here is this field here called apply immediately, right? So if you check this, that means the changes will be applied immediately, and that may require a reboot, right? So your application may see some, you may have some disruption, right? Your users may see some errors, right? So that's why if you are okay with the change happening later in a maintenance window, then do not select this field. All right, okay, all right. So that was modify, and in this question, basically, yes, you can easily change the deployment option with the modify action, right? There is no need to configure database configuration or to change the database configuration files. Right, all these things are done by RDS. You don't have to go into the operating system and change the database configuration files. All right, so if that was what your question was, right? If you have a follow-up, let me know. Okay, all right, okay, folks. So I think let's stop here. We've spent, I think, enough time on RDS, which is fine. But this is the most important service. It's likely that you'll use RDS before any other option, right? So it's good that we spend more time on RDS. But now let's move on, right? Let's move on to the next topic that we have. All right. So now let's talk about Dynamo DB, right? And this is NoSQL. It's NoSQL, very different from, say, what we've seen before, right? Oracle, SQL Server, MySQL, etc. It's a completely different technology, right? And DynamoDB is, a service, a NoSQL option, right? There are other options like MongoDB, Cassandra, right? DynamoDB is a proprietary technology from AWS, right? And that's very important to know and understand. Because as a solutions architect, again, right, you have to know the differences, and you have to make a conscious, well thought out, well analyzed decision as to what you're going to do, right? Will you use DynamoDB, or will you use something else like MongoDB or Cassandra, right, on EC2? So those kinds of decisions you have to make. So it's important to understand the distinction between these technologies. Okay, so DynamoDB, right? Let's understand what this is. So it's a fully managed, right? It's fully managed, which means when you hear the word fully managed, what it means is you don't have to worry about things like backup, right? The infrastructure side. You don't have to install, do patches, updates, right? None of that has to be done. It's fully managed. Okay, you just become a user, right? You have a NoSQL database in front of you. You simply start using it, write your applications, right? That's all you have to do. You don't have to do anything else when it comes to DynamoDB. Okay, so it's a fully managed service. All right. Okay. Also, of course, NoSQL and DynamoDB can be used for extremely large databases. Right? So you can have millions, tens of millions. You can also have billions, billion with a B, right? You can have billions of records as well, right? DynamoDB can scale to a very, very large size, much more so than traditional databases like Oracle, right? Oracle is known to be, the premier database, right? It is supposed to be very scalable, very good, but DynamoDB and NoSQL in general can surpass that as well. So, okay, so NoSQL, one of the advantages is it's highly scalable, more so than traditional databases. Okay. Also, you can see here in the picture here at the bottom, right, the interaction between your application or between the user and DynamoDB is over HTTP, right? So it's, the requests are made using over HTTP using the AWS API, right? So you have software development kits which incorporate, which give you those classes and methods, so you can use them and get access to the API, and you basically request over HTTP.
And so there's no standard sort of protocol here, right? So there's no JDBC, ODBC, those kinds of things, right? You have to use the AWS API for DynamoDB to sort of interact with the database. All right, okay. So that's one difference right away. All right. So what are the benefits? Why should we use DynamoDB? Right. Okay. So let's take a look at a few of these. So one is it gives you fast and consistent performance. So this is both a feature of NoSQL. Right. NoSQL can be faster than traditional relational databases. All right. And also maybe part of it is DynamoDB itself, the technology that is behind DynamoDB. Right. So it's much faster than traditional databases. Okay, NoSQL, again, NoSQL can be scaled much better than relational databases, right? That's another strength of NoSQL compared to SQL or relational databases, right? Okay, the other side is DynamoDB on the hardware side, on the infrastructure side also is much more scalable, okay? Because it doesn't have the same server type of technology, okay? So DynamoDB is very similar to S3 in that sense. It's a pure cloud technology, right? And you'll see when we use DynamoDB that there are no servers here. There are no servers like in S3. S3 if you compare to EBS, right? S3 is more modern, more cloud-like, right? Same way, DynamoDB when you compare to RDS is more modern, more cloud-like. Okay, RDS is very traditional, right? It's basically servers with database server installed on it, right? With some automation. So it's value add over what we already had, right? But DynamoDB is completely different, right? It's totally cloud-like in that there are no servers. You can scale simply by specifying how many reads you're going to have per second, right? So you don't say I want 10 servers or something like that. You simply say I'm going to have so many reads per second, right? If you need more, you simply go and change the number of reads per second that you want. Okay, so it's highly scalable. Both from NoSQL in general tends to be more scalable, right? So there's a software component to it, but also on the infrastructure side, it's a completely different design. It doesn't use the same traditional server type of architecture. Okay, all right, and then it's fully managed, of course. So you don't have to worry about installation, configuration, security, patches, upgrades, right? None of that, right? You don't have to worry about scaling as well here. Right, you don't have to say, okay, I want to go from small server to large server. Nothing of that sort, right? It's fully managed. You simply are a user, and you can configure it, right? You can decide how much of capacity you want, right? So you can do a little bit of configuration, but otherwise, it is fully managed. All right, okay. So these are the major benefits. Let's go ahead. Okay, so here's a use case, right? Just to give you some real life example, right? So here, there's a company called Duolingo. You might have heard of it. It's a language learning site, right? So you can learn any language, Spanish, French, etc. So my son, for example, he uses this to learn French, right? And it's a very good app, right? But that's separate, right? The functionality of the app is different. The main thing here, from our perspective, is that it actually has lots of data, right? So it basically has language snippets, like say, how are you, right? How do you say that in French, let's say? So those language snippets are sort of stored in DynamoDB, and you can see here on the slide it says there are 31 billion items. Okay, 31 billion items in the DynamoDB table or database for Duolingo, right? It's a very popular app, right? Millions of users. And of course, there's lots of concurrent, access to the database as well. So that's another important thing. But as far as storage is concerned, you can see 31 billion items is a very large number, right? Even for Oracle, these kinds of numbers will be difficult. Okay, so NoSQL and DynamoDB are meant for, or rather, they can be used for smaller database, of course. But even if you have use cases like this one, right, a truly internet scale service. Right? That's what is happening in the world right now. You have, because of cloud, partly, you have global companies, right? Global services like Facebook or Google, and Instagram, and all these things, right? So these are global companies. They have users all over the world, right? And that kind of scale was not seen before, right? Like Oracle, when it became the major database, you had big companies, but nowhere near the kinds of scale that modern internet businesses have, right? So that's what DynamoDB does, right? It can help you with these kinds of use cases where you have really large global sizes in terms of records. Okay, now the implementation side, right? So let's talk about the implementation side. So basically, DynamoDB, you create tables, right? In DynamoDB, there are no foreign keys, right? It's a NoSQL technology, so there is no foreign key. There are no joins as well. Okay, no joins, no foreign keys. So everything has to be in a single table, right? And the table therefore becomes like a database, right? So the table is the database. All right, all your data is dumped into a single table. There's no join, right? There's no foreign key, so you have to pull everything up from the same table, right? You can have other tables, of course. You can have as many tables as you want in your application, but there's no way to join. All right. Okay, so you create your table, and then you can add items, right? An item is like a record in the traditional database, right? So you can add items into your DynamoDB table, right? You can add, like we've seen before, you can add millions, tens of millions, and even billions of items into a table, right? And then you can query, right? You can query because it's a database at the end of the day. So you can query, you can do, say, a scan, so you can list all the items, or you can query on a very specific primary key, right? So those kinds of things can be done on DynamoDB. All right. Okay. And finally, you have monitoring and management, right? So remember, it's not a database in the traditional sense, right? So if you're running Oracle on a server, normally what you'll do is you'll monitor, or you'll maintain, you'll manage by connecting to the server, right? Connecting SSH to the operating system, or RDP to the Windows server, right? From there, you will look at your database, look at your processes, look at your database logs, and so on, right? That's how you would monitor and manage your databases. But here, there's no server, there's no operating system, there's no SSH, no RDP, right? So what do you do? How do you manage, right? So that's why DynamoDB itself will give you some management capabilities, right? And some monitoring capabilities. Okay, so it's all part of the DynamoDB dashboard because there's no server here. All right, okay. So I hope you're seeing the difference between DynamoDB and RDS, right? RDS is more traditional, right? It's all technology with a bit of cloud capabilities, right? But it's still traditional technology. DynamoDB is totally different. It's a cloud service, right? It's totally different. It takes a bit of time to get used to these things, right? But you'll once you start using it, you'll find that it's totally different. It's probably much better and much more scalable, much more easy to use, right? So that's what DynamoDB is. All right. Okay. Before we see the demo, let's do a quick comparison of SQL and NoSQL, right? And this is not just AWS specific, right? It's general comparison. Okay. So SQL is the old, or rather, well, let me not call it old, right? But the traditional databases, right? So relational databases, Oracle, MySQL, etc. Okay. And NoSQL is MongoDB, Cassandra, and DynamoDB, right? There may be other options as well. So NoSQL is more recent, right? It's more recent. SQL has been around for a while. Relational databases have been around for a while. Okay. Now, what was the reason, right? What was the reason for NoSQL? So NoSQL has emerged because the world is changing, right? The world is changing. Like I said, now you have global companies, right? Internet scale businesses. Basically, it's the spread of internet, right? The internet is becoming available to more and more people, right? So more and more people can now use services like Facebook, right? Facebook has 2 billion people now, 2 billion users, right? And 1 billion of them are active users, right? They use it on a daily basis, right? I don't know about you, I don't use it, but you may be someone who uses Facebook on a daily basis. Right? 1 billion people in the world use it on a daily basis, right? And then there are 2 billion people, right? I would be in the second billion, but I do have an account, but I use it less, right? So there are 2 billion total users with 1 billion active users, right? So this kind of scale was not seen before, right? Especially when Oracle and these other database technologies became prominent, right? So that's what is happening, right? You have newer types of businesses, very large businesses that are emerging, thanks to the internet mainly, right? And also, we have now we have more access. We are more connected. We have mobile devices, for example. So a lot of people are using these services more. The amount of data being generated is a lot more than was possible before, right? And there's a network effect, right? More and more people, more and more applications, more and more data. You have IoT as well, right? Internet of Things. So devices are being connected. So it's simply that the world is changing very rapidly, and a lot more data is being generated, right? So that's why NoSQL has emerged, because the traditional database technology was not sufficient, right? It was not able to keep up with this changing world, right? So that's what NoSQL is, and that's how it emerged. Okay, so NoSQL works better at large scale, right? It is better, or it performs better when the amount of data and the number of items, the number of records is very, very large, right? Like Duolingo or Facebook. Okay, so that's one difference. The other difference is that NoSQL is also schema-less, in that you don't have to define the structure of your table in advance, right? So in traditional databases, you have to create a table, then you define each column, right? You say, okay, name, this much length, this type, right? Age, it's a number, it will have this much of size, right? So you have to predefine your table structure in advance, right? Whereas in NoSQL, you don't have to do that. Okay, you have to only define the primary key, and then the rest of it can be sort of created on the fly, right? So when you add an item, when you add a record, you can define what fields, what attributes each item will have. Right? You don't have to predefine it. So that's better, because it's more flexible, right? So when you in traditional databases, when you change your database structure, you have to sort of alter your table, and that leads to problems. You have to sort of change your application. You need some testing, right? So in NoSQL, there's no such thing, right? It's very, very flexible right from the start. All right. Okay. Another difference between NoSQL and SQL is that traditional databases can only be vertically scaled, right? That's mainly because you have foreign keys and joins, right? So you can't spread the data over multiple servers, because then joins become too complicated, right? So, but because with NoSQL you have no joins, no foreign keys, NoSQL databases can be scaled horizontally quite easily. Okay, and that's always good. Horizontal scalability is always good, because you can only scale vertically to a limited amount, right? How big a server can you have, right? But with horizontal scalability, you can scale to whatever number, right? You can have 100 servers, 200 servers, 500 servers, right? You can scale to whatever number, right? And that's always good, right? So for these reasons, NoSQL is better for web scale applications, right? But that doesn't mean NoSQL will replace SQL, right? SQL will always be there, because SQL is good for queries and analysis and joins, right? That need will always be there. Okay, so what you have to do is you have to use NoSQL at the appropriate place in your application. You have to use SQL at the appropriate place in your application. Often you will use both, right? They're not really competing, right? They're not really competing. They are to some extent complementary, right? So you may end up using both in your applications. Okay, so you have to think about these things. All right, so now let's take a look at DynamoDB, right? And maybe we may not finish today, right? We may not finish totally, so we'll continue tomorrow. But let's take a look at DynamoDB a little bit today. Okay, so let me go to DynamoDB here, right? And here, let's go right ahead and create a table, right? Remember, we're not calling this a database, it's a table, but it's like a database, because there's no foreign key, no joins, everything will be in the table. All right, so by the way, there's an inbuilt tutorial that you can use, right? When you're practicing, just click on the tutorial and it'll give you a step-by-step instruction. Okay, so I'm just using the tutorial. I'm just doing what the tutorial says, right? So let's say we want to create a music table, right? So let's say we have an ambition to create the world's largest catalog of songs. Okay, and I'm giving you this example because I want to highlight to you that DynamoDB is meant for large internet scale services, right? So let's say, a good use case would be the largest catalog, right, or the most complete catalog of music or songs ever created in the world, right? So we're going back historically, right, and collecting details about all the songs in the world, let's say. Okay, so that would fit right into DynamoDB. Okay, DynamoDB would do very well, much better than Oracle, let's say, when it comes to this kind of large database, right? Okay, so let's call it music. This is our the name of the table. All right. Next, what we do is we have to define the primary key. Okay, that's a very important part of the NoSQL database, right? So let's say the primary key is artist, right? Artist is the person who sings the song, right? And sometimes also writes the song. So this is the artist, right? And the primary key has to be unique though, right? Now this artist will not do because one artist can have many songs, right? So we're creating a catalog of songs. So this is not really unique. So what we can do is, in those cases, we can add a sort key, right? Separate another key, and this is a composite key, right? Where you have two keys together combining to form the primary key, right? So it's not necessary to use the sort key, right? Depends on the situation. But here we need to have a sort key, and let's say the sort key is song title, right? The name of the song. So this combination, artist and song title, will be unique, right? You'll agree. There may be a very small chance of a conflict, but in general, this will be fine. All right. Okay. So that's our primary key. That's it. That's our primary key. Okay. You don't have to define any other field. That's what NoSQL is, right? It's schema-less. You don't have to define any other field. All right. All right. Now that's it. You can create a table. Okay. But let's take a quick look at the default settings, right? Let's look at some advanced settings here. For example, the capacity, right? The capacity, the hardware capacity. So here, like I told you before, we don't have servers. There are no servers. It's a cloud service, created on the cloud, right? It's not some historical technology being ported on the cloud, right? It's a cloud service. There's no server here. All right. So what you do is you define the read capacity units and the write capacity units, which means how many reads per second and how many writes per second, right? Now, 5 per second is too much. This is just a demo, so I'm going to reduce this to 1, right? 1 read per second is fine. 1 write per second is fine. So then the cost of this would be about $50 per month. That's it, right? $50 per month. That's it. That's the cost of your NoSQL database. All right. Okay. So let's create this table. All right. Now there's no server, right? It comes up immediately. There's no need to wait. There's no server being provisioned here. The table will be available immediately, right? In just a matter of seconds, it should be available, and then we can start using the table. All right. So now we have a table. The music table has been created. We can start using it right away. So I'm going to add a few items, right? I'm going to add a few items. So let's say, we'll add an item, right? Let's say we want to add some songs here, right? It's the world's largest collection of songs. So let's say, we have let's look at, say, some Western music, right? So there's an artist called Bob Dylan, right? Bob Dylan, you might have heard of him. Recently won the Nobel Prize for Literature, actually, right? So Bob Dylan, and let's say, there's a song called Tambourine Man, one of my favorite songs. So there's a song called Tambourine Man. Okay, so this is your song title, and this becomes one item, right? Now remember, you can add many more fields. You can add as many fields as you want. So for example, you can say what's the genre, right? Genre means what type of music it is. So maybe it is called rock music. I don't know, right? Maybe let's say it is rock music. So this is the genre. Okay. All right. Now more fields. So maybe album, right? You want to have album as well. So maybe it is best of Dylan. All right, and so on and so on. You can keep adding, right? You can have thousands of attributes, no problem, right? No problem. You can add thousands of attributes. It will work. All right, and now we can save. Okay, so this is your first item, a first song in this catalog. Let's add one more, right? Let's add one more. So another song, let's say again from Bob Dylan. All right, this song, let's say it's called Like a Rolling Stone. Okay. All right. Now you can add more fields, right? But the fields don't have to be the same. They can be different. They can be different. Okay. So for example, what year did the song come out? So maybe this came out in 1975. All right. We can add more fields like album and genre, but not necessary, right? Not necessary. One item can be different from other items, right? So this is why it is called schema less. Okay, schema less. You don't have to have a rigid structure, right? Each item can have its own set of fields as long as you have the primary key. Okay, primary key has to be there, but other fields, the other attributes can be different. All right. Okay. So this is two items. Now one more. Let's add one more. Let's say Tracy Chapman. Right. I don't know why. I just remembered Tracy Chapman. Right. I remember she won a Grammy many years back, and she had a famous song called "Fast Car." All right. And you can add whatever let's say year. Right. Maybe this was, I don't know, 1990, something like that. Okay, so you can add as many items as you want. You can have 1 billion items, even more. So this is how you add items, right? Okay, now on the read side, now you have to query, right? A database is meant for querying. So on the read side, you have two basic operations, right? One is called scan, and the other is called query. Okay, a scan is basically, just a listing, right? You do a search, it'll give you a list of all your items, right? You can add some filters. So for example, you can say, okay, any artist equal to or starting with, say, Bob, right? Something like that. So you can do some filtering, right? You can do some filtering like this, but that's what a scan is. It's like a listing of your items, right? The query is different. The query is more specific, right? Query is more specific, and you need to specify the partition key in full, right? So something like this, you have to specify it in full. All right, and then the sort key can be very specific, or there can be a little bit of flexibility here, right? So let's say starting with the T. Okay, so you have some flexibility, but you can also be very specific, right? So this, it can be something like this, tambourine man, right? So very specific query, and if you run this search, it should give you your song. I think I may have misspelled it, right? I don't know. Anyway, okay. So let's say something like this. Yeah. So I had misspelled it. So this is a query, right? And this query, by the way, is usually very fast. I mean, it's always very fast. Okay, it's very fast, and that's the strength of NoSQL. That when you have a very specific query using the primary key, right, or at least the partition key, the response is very fast. Okay, this is the strength of NoSQL. Okay, the queries responses are very fast, right, and the database is very flexible, and the structure is very flexible as well. All right, this is DynamoDB, right? This is DynamoDB. Okay, let's do a little bit of Q&A. Tomorrow I'm going to continue with DynamoDB, and I'm going to show you how to use DynamoDB in your applications, right? We are not going to be creating items and querying items from here, right? This is just for test, right? Your applications have to use DynamoDB. Okay, so that we will talk about tomorrow. But at this point, let me see if you have any questions, right? Let's finish up these questions and we'll continue tomorrow. Okay. All right. So let's look at this one. Subhani, can you please explain what is vertical scaling and horizontal scaling? Yeah, sure. So vertical is, up and down, which means, larger server or smaller server. Okay, but it's just one server, right? One server being changed to a larger server or a smaller server. All right, that's what vertical is. And horizontal is it's called in and out. Okay, in and out. Scale in, scale out. Okay, or rather scale out first, right? Scale out and in, which means more servers or fewer servers. All right. Horizontal scaling is better. Okay, because you can scale to whatever extent. You can have hundreds of servers, right? Whereas vertical, you can go to 50 GB, say 100 GB of RAM, right? It's hard to get something bigger right? So that's a yeah. This is also a good one, right? This comment is a good one. So vertical scaling simply means increasing the, the CPU memory and disk space in the same server. Right? That's a good one. Okay, so that's what it is. Vertical scaling is usually done with databases. Horizontal scaling you normally do with app servers, web servers. All right, that's an important point as well. So vertical is for databases. Okay, for databases normally, and horizontal is used for app server tiers, web server tier, stuff like that. All right, okay, so that's how it is. So databases have usually been, you can only do vertical scaling, which is a problem, right? But NoSQL solves that problem. You can scale NoSQL horizontally, right? Whereas traditional relational databases were hard to scale vertically, right? Okay. Can DynamoDB support secondary indexes? Yes, you can create secondary indexes. Yes. Okay. All right. Next one, Babita, how do we upload a text file into DynamoDB without doing manual creation of records? Yeah, we'll talk about it tomorrow. Okay, so you can do it using the API. You can use the API. There are some batch operations, etc. Right. So there are multiple ways of doing it. Okay. So also the SDK. So we'll talk about it tomorrow. It's coming up tomorrow. All right. Let's do this as well, these two, and then we'll end the session. So Gajendra, DynamoDB, if it is so fast, then would it be advisable to use DynamoDB over Oracle? What's the use case where Oracle is recommended or DynamoDB? Yeah, so yeah, it can be used, right? Definitely it can be used with over Oracle, right? So remember, NoSQL has no joins, okay? No joins, no foreign keys, right? So this is good for large scale, right? Large scale sets of data, okay? Very large scale. This is very good. All right, and also very good performance. Performance is very good. All right, okay. SQL or Oracle is good for query, analysis, joins, foreign keys, right? So these kinds of situations, Oracle is better. Okay, NoSQL cannot do what Oracle can do, right? And also vice versa. Okay, so we'll talk about some examples tomorrow. Okay, we'll talk about more examples tomorrow. All right, and last question. Okay, Shyam, you saw accessing the RDS using an endpoint, but suppose I have a simple Java application to access RDS. How do you use JDBC connection? Then we need to specify the connection, URL, hostname, server, etc. Yeah, same thing. So RDS endpoint, right? So let's say you have an Oracle JDBC connection, right? So what do you need? You need the host. This is your RDS endpoint, right? What else do you need? Do you need the port? This is the MySQL port, right? Or whatever, Oracle MySQL port. What else? You need the username, right? This is your database username that you can create. It can be root or app specific, right? So these are the things you need, right? And all that is available. Okay, all this is available. All right. So same thing. It's the same thing. All the details required for a JDBC connection, ODBC connection is available. All right. Okay. So no problem. This is not a problem. Okay. All right, folks. So I think we are over time. So let's stop here. You can do some further reading about RDS and DynamoDB. We can discuss, maybe spend more time tomorrow as well. Okay. But when we start tomorrow, we'll continue with DynamoDB and then talk about the other two services as well. All right, folks. That's it. Have a good night, and I'll see you tomorrow.